Students, in my previous lecture, I told you about the Coulomb's law, which is used to calculate the force of interaction between 2-point charges. Now, the question is, if there are more than 2-point charges, like 3 charges, 4 charges, 5 charges, suppose that 100 charges are there, then how we will apply this Coulomb's law? For that, we use principle of superposition. So today I am going to tell you about the principle of superposition, and you can understand this principle in this simple way. Suppose that here is the collection of charges like this. So many charges are like this, so many charges. Like this charge is Q1, this charge is Q2, this is Q3, this is Q4, this is Q5, this one is Q6, this one is Q7, this one is Q8. And there are several distances among the charges. In this way you can draw. Let this distance is R1, this is R2, R3, R4, R5, R6, R7, R8. In this way you can just show the distance. Let this point is A, this point is B, C, D, E, after that F, G, H. And you want to calculate the force of that charge which is kept at C. Suppose that you want to calculate how much force is acted here. Then because here you can see not only 2 charge, so you cannot simply apply that Coulomb's law to calculate the force. For that we are using principle of superposition. What is this principle? We want to calculate force at C. We will write in this is equal to the vector sum of all the forces applied by the point charges which are kept at the different point over the point C. Means what? We force acted over C by A plus force acted over C by B. No need to write C because at C you are calculating force acted over C by D, force acted over C by E, force acted over C by F, force acted over C by G, force acted over C by H, and this must be vectors. Means when we calculate the force, we should also observe the direction. This is called principle of superposition. This principle of superposition you can understand more better way by taking an example like this. Suppose that there is a line and over that line 3 charges are kept. Let the points are A, B and C, and charges are -1 coulomb, +2 coulomb, +3 coulomb. Suppose that these 3 charges are there. The distance between these 2 points let 1 meter, these 2 points let 2 meter. Now the question is, what is the total force acted over B? Total force acted over B, we apply principle of superposition because here charges are more than 2. Here 3 charges are there. So we apply principle of superposition. Means except B, other 2 are A and C. Yani force acted at B due to A plus force acted at B due to C. And this must be vector sum. Now question is how we calculate these forces. Suppose that I am going to calculate FBA. For that FBA we are going to calculate by Coulomb's law 9 to the power 9 into Q1. B and A, that is 2. A, that is 1 upon distance square means 1 meter. This is 1 square. Now what is the direction? Force at B due to A, यानी A क्या कर रहा है B पे? A is negative, B is positive. A क्या करेगा B को? It will attract. So when it will attract, then B will come towards where? It will come towards A. Means the direction will be BA because it will attract. So you will write here towards B. Now this is the direction. In the same way, one more force is left, that is FBC. FBC, Coulomb's law gives magnitude. B is 2. C is 3. Distance square, that is 2, means 2 square. Now direction. C क्या कर रहा है B पे, means what the nature of force is producing by this point charge over this point charge. You can see both are positive, so C will repel. So if C will repel, so C will repel means where it will go. If you see the figure like this, it will go towards left, your left side, towards left, and for first one also towards BA, or you can say or towards left, here also towards left. Now you can see both the forces are acting towards left, means what? If here is B, then this is two arrows I am putting here, one arrow for FBA and one arrow for FBC, and both are in the same direction, therefore resultant force, that is FB, will be, because both are in same direction, so in magnitude we will directly add them, add this one with this one. When we will add this one, it will give magnitude, and when you write direction, because both are towards left, so the resultant direction will also be towards left. In this way you can solve the numericals if you want to calculate force over any one charge due to collection of number of charges. My dear students, like this there are so many examples. Like if triangle is there, suppose that triangle is equilateral, means all the sides are same. Here it is plus 1 coulomb, here it is minus 2 coulomb, here it is plus 3 coulomb, and you want to calculate, suppose that this point is A, this point is B, this point is C, and you want to calculate force at A. You can apply simply this principle of superposition and you can calculate. So my dear students, just try to solve the numericals like this: triangle shape, rectangle shape, square shape, and like this line charge. You can increase number of point charges here and you can calculate the result. And if you feel problem, you can give me the question, I will reply you answer. Thank you. God bless you all.